Hey yo, so today we're gonna look at the M25 AAHL Paper 1 time zone A. We're gonna look at the first question concerning a cubic function with a local minimum at P and Q. We are asked to find the values of P and Q. This is a very straightforward start of a paper. All we gotta do is find the derivative, set it equal to 0, recognizing that the x-coordinate of the local minimum is positive, we can deduce that P is equal to 2. Finding the value of Q, we simply plug this P value back into our F. And voila, that's your value of P and the value of Q. Easy 5 marks. Question 2 is on compound interest. Bob invests 1,000 dinar in an account which pays a nominal annual interest rate of 4% compounded quarterly. The amount of money in the account after one complete year can be written as 1,000 times 1 plus k to the 4, where k is a rational number. So part A asked us to find the value of k. So we know that k is equal to 4% divided by 4. 4 is a number of times the money is compounded in a year. And that should give you 0.01. Part B is a simple application of the binomial theorem. So in this case, it's going to be 1, 4, 6, 4, and 1. Now we're going to fill in the powers. That's it. Done. In part C, we would like to find the amount of money in Bob's account after a year, which can be given by this expression. We can expand this bracket using the answer to part B, replacing x with 0.01. Simplifying this expression is a little tricky because there are too many zeros. And that will give you this number. Since we're asked to round our final answer to the nearest dinar, your final answer should be 1,041 dinars. Not rounding your final answer will automatically cost you a mark. Question 3 of the paper is another calculus question. We are asked to find the area enclosed by the curve y equals e to the x, y equals negative e to the x, and the lines x equals negative 1 and x equal to 1. It is always a good idea to quickly sketch the region that we are trying to find the area. This sketch does not have to be accurate. This is y equals to e to the x. This is y equals negative e to the x. We're integrating between negative 1 and 1. So this region here. Setting up the integral to find this area is trivial. So the area is going to be from negative 1 to 1 of the upper curve, e to the x, subtracting the lower curve, negative e to the x. The integral of e to the x is e to the x. And that's the end of the question. You may choose to leave your final answer in this form or in this form. Both answers are accepted. This is question 4 of AAHL Paper 1 time zone A. This question is on probability and probability notations. You're given 3 probabilities, and then you're asked to find the probability of A intersecting B. Then you're asked to show that A and B are independent. So let's start with the first part. We are given that P of B given A is 2/3. Using the definition of conditional probability, P of B given A is equal to P of A intersecting B divided by P of A. To find P of A, we can take 1 minus P of not A. Thus, P of A intersecting B is equal to 2/3 times this, or 1/6. This is also region B on our diagram. In part B of the question, we're asked to show that A and B are independent. To do this, we have to show that the probability of A union B is equal to the probability of A times the probability of B. We already found this. What's left is finding the probability of B. Going back to our Venn diagram, we were given that the probability of not A is 3/4. This means C plus D is equal to 3/4. We are also given that probability of A union B is 3/4. That means A plus B plus C is equal to 3/4. Our probabilities is equal to 1. From these two equations, we can deduce that D is equal to 0.25. And if D is 0.25, C is therefore 0.5. The probability of B, therefore, is B plus C, just 1/6 plus 1/2, or 2/3. So let's check. PA times PB. PA we found to be 1/4. PB we just found to be 2/3, and that's 1/6. P of A intersecting B is also 1/6. Therefore, the left-hand side is equal to the right-hand side. And therefore, A and B are independent. This is question 5, and this question is on geometric series and a bit of statistics as well. This is a very nice question, I gotta say. So we have a sequence of 10 rectangular picture frames from F1 to F10. Picture frame F1 has width 4 cm and height 5 cm. The width and height of picture frame Fn are each increased by 50% to generate the width and height of the next picture frame Fn plus 1. In part A, we are asked to show that the area of the frame Fn is equal to 20 times 9/4 to the n minus 1. And then we're asked to find the mean area of the 10 picture frames. So let's do that. The first picture frame has width 4 and height 5. So the area is 4 times 5, or 20. For the second frame, the width has been increased by 50%, or 3/2. The height has also been increased by 3/2. So the area is now 4 times 5 times 3/2 squared. Similarly, we have F3. The new width has been increased by 50%. The new height has also been increased by 50%. So the new area is now 4 times 5 times 3/2 to the 4. And we can see that this is indeed a geometric sequence with first term 20 and the common ratio with a common ratio of 9/4. This means that the area of the frame N, that's gonna be 20 times 9/4 to the n minus 1. To find the mean area of the 10 picture frames, we gotta find the sum of the areas of a 10 picture frame, then divide by 10. So the mean area is gonna be the sum of the 10 picture frames divided by 10. The first one is 20. Now we have 20 times 9 by 4 plus 20 times 9 by 4 squared, and so on until the last term. Divide by 10. Notice that the numerator is a finite sum of a geometric sequence. So the sum of first n terms of a sequence is a times 1 minus r to the n divided by 1 minus r. In this case, our a is 20 and our r is 9 by 4. Our n is equal to 10. The denominator can be simplified. So your final answer would be 16 times 9 by 4 to the 10 minus 1. In other words, P is equal to 16, A is equal to 10. So that's the end of part A. In part B, we're asked to find the median area of the frames. So if you write out the sequence of the areas of the frames, the median is therefore the sum of the fifth term and of the sixth term, as this is an increasing sequence. The fifth term is 20 times 9 by 4 to the 4. The sixth term is 20 times 9 by 4 to the 5 divided by 2. Since our answer is a constant times 9 by 4 to the 4, we have to factor that 9 by 4 to the 4 out. And then we're left with 20 plus 20 times 9 by 4 divided by 2. And this term then simplifies to 65 divided by 2. Hence, Q is equal to, that's a 4, 65 divided by 2.